Okay, so question 9 is done. Now question number 10. The equation of a curve is this: y equals to 5 minus 2x to the power 3 over 2 plus 5 for x is less than 5 over 2. A point P is moving along the curve in such a way that the y coordinate of the point P is decreasing at a rate of 5 units per second. Find the rate at which x coordinate of point P is increasing when y is equals to 32. So what have they given us? First is dy over dt, because the y coordinate is decreasing at a rate of y coordinate decreasing 5 units per second. 5 units per second decreasing means negative sign. Okay, whenever the rate is increasing, then we use positive, and whenever the rate is decreasing, we use negative. So this is decreasing at 5 units per second. Now the rate at which, find the rate at which the x coordinate of point P is increasing. We need to find dx over dt when y equals to 32. Okay, we need to find dx over dt. Okay, I need to just adjust it a bit. Yeah. Now what are we supposed to do? We have a connecting equation of dy over, let's take simply just y first. So we have a connecting equation of y to be y is equals to 5 minus 2x to the power 3 over 2 plus 5. Okay, how do you use this chain rule in these rate questions? That dy over dx will be equals to dy over dt times dt over dx. Okay, so here what do we need? This is what we need to find. This is given. Dx over dt we need to find. So we'll just do the reciprocal of it later on. Right now we'll just find dt over dx, and we have dy over dt given to us to be minus 5, and we have to find dy by dx also. So let's do that. So dy over dx would be nx n minus 1, so 3 by 2, 5 minus 2x to the power 3 over 2 minus 1 times the derivative of the function, so it would be minus 2 plus 0. So let's simplify this now. Minus 3, 5 minus 2x to the power 1 over 2. Okay, we get this to be derivative. Now substitute in each value in this chain rule. So we will get minus 3 times 5 minus 2x to the power half equals dy over dt to be minus 5 minus 5, and dt over dx is that we need to find. So what to do? When y is equals to 32. So let's first rearrange this. Okay, so it will be equals to dx over dt equals minus 5 over minus 3 times 5 minus 2x to the power 1 over 2. Now the thing is, they have given you that find dx over dt when y is equals to 32. they haven't given you any x value, but we need an x value here. Okay, so actually we should be needing x value. So what to do? First find the x value for this y is equals to 32. We have the equation of the curve. Okay, and we just be substituting y equals to 32 in this to get x equals to whatever we have. Okay, so let's, instead of doing somewhere else, let's do it here. We have some space. So yes, y, okay, substituting 32 equals 5 minus 2x to the power 3 over 2 plus 5. 32 minus 5 would be 27 equals 5 minus 2x whole power 3 over 2. Squaring both sides will give you and taking cube root, like actually taking on both sides power multiplying by 2 over 3. So it will give you, directly do in the same step. Instead of doing this, let's do 27 the power 2 over 3 and this 3 over 2 whole power 2 over 3. So what we will be left with? We'll be left with here 5 minus 2x equals 3 square 9, and 2x will be equals to 5 minus 9, that would be minus 4 over 2, that would be minus 2. Okay, so we'll be left with x equals to minus 2. So we are left with here minus 5 over minus 3, 5 minus 2 times minus 2 whole power 1 over 2. So now simplify this. 5 plus 4 would be 9, and square root of 9 would be 1 over 2 power means square root, so 9 would be 3, so 3 times 3 would be 9, so 5 over 9. Okay, so this is your final answer for dx over dt. The rate of change of x with respect to t is 5 over 9. Okay, so whatever they're asking us in question number 10, that equation is given to us of the curve. The y coordinate is decreasing at 5 units per second, so means dy by dt. And we need to find the rate at which x coordinate is increasing. So as also clear from here that this is a positive one, so that means that the rate is increasing. So we are going to use the chain rule for this. We have a connecting equation y is equals to this. So we'll differentiate it, substitute in that's this derivative and dy over dt value, and then the important thing was that we had y is equals to 32. Instead we should be having the x value, so we found x value by putting y value in the original equation. Okay, in this equation putting y equals to 32 to get x value, and that x value we get to be minus 2, and in this way we have found dx over dt clearly. Okay, now let's do the part B of it. Okay, so part B says point A on the curve has coordinate y coordinate 32. Point B on the curve is such that the gradient of the curve at P is minus 3. Find the equation of the perpendicular bisector of AB. Give your answer in the form. Okay, you had any curve whose equation was this, and we found a point on this curve whose y coordinate was 32. So is it the same point whose y coordinate is 32 and x is -2 that we found? Okay, so they are saying the same. Point A on the curve has y coordinate this, and point B on the curve is such that, so using point A, that is -2 and 32, and B is such that at B gradient is -3. So what do we need to find? We need the equation of perpendicular bisector. So how can we find the perpendicular bisector? Then if the gradient of the curve at B, for example, your curve is this is your point B. So perpendicular bisector would be this line. How can you find the equation of this line? If we know the slope of it, slope of this perpendicular bisector, and we know the point B. Obviously, it is passing from point B. So if we can find the point B and its gradient, then we can find the equation. So if the gradient of the curve is -3, then gradient of perpendicular bisector would be wait, the perpendicular, we don't need the perpendicular bisector of the tangent. We need a perpendicular bisector of AB. There is some point A here, B here. So we need a perpendicular bisector of this AB line. Okay, so we need the slope of this AB and then perpendicular bisector of AB. So it seems a little different. So let's look into this again. First we need to find the points A and B, then we can move further. So if we know the gradient, then how can we find the point B? As we know that gradient is -3 at point B, then what we can do is, what is this actually given? Dy by dx is given to be -3, or yeah, dy by dx. And what was dy by dx? We found it to be here. This was -3 times 5 minus 2x power half. So -3 times 5 minus 2x to the power half equals -3. So what we can do from here, we can get the x and y values for point B. So x will be equals to 5/2. -3 or -3, it would be 1. Sorry, not 0. So it will give you so x equals to 2. Now substitute this in the y curve equation. And what is y? The equation of curve is this one. So if x equals to 2, then y will be equals to 5 minus 2 times 2 power 3 over 2 plus 5. 5 minus 4 would be 1 and 1 plus 5 would be 6. So what we are doing from the gradient at b, that means at b the derivative is minus 3. So from that we are equating it to the derivative that we already found in part A, and we are getting x value and y value. These are coordinates of point B, 2, 6. Okay, so now we are having point A as well as point B. Now what we will be doing, we will be finding our slope of AB. Okay, also we will be finding the perpendicular bisector, so we will be needing midpoint of AB to get the equation of AB. Okay, MAB and midpoint of AB. So we can use, I'm writing here what we are needing for it. Midpoint of AB, and then we will be using the point slope form, y minus y1 equals xm times x minus x1. So first find slope of AB. Where is point A? Minus 232. So minus 232 and 2 and 6, A and B. So it would be 6 minus 32, y2 minus y1 over x2 minus x1, 2 minus minus 2. So we will be having minus 26 over 4 minus 13 over 2 is the slope gradient of line AB. Now we need actually the perpendicular bisector slope. So slope of perpendicular bisector of AB would be 2 over 13 because negative reciprocal. Okay, and now midpoint of AB would be x1 plus x2 over 2, y1 plus y2 over 2. So minus 2 plus 2 over 2, comma 32 plus 6 over 2. So it will give you 0, comma 38 over 2 will give you 19. So let's write down the equation of the perpendicular bisector. As on the line AB, this is for example AB line, we need the perpendicular bisector equation. This is your perpendicular bisector that we need to find. Okay, so for this one we have the midpoint and we have the slope of perpendicular bisector. So let's use that. Y minus, what is y1? Y1 is going to be the midpoint. We are taking the midpoint, no? Y minus y1 equals m. What is slope of perpendicular bisector? 2 over 13. 13 times x minus x1, x minus 0. So it will become 13 times y minus 19 equals to x. And then we will be having 2x minus 13y plus 13 times 19 would be 247. Okay, so this is your equation of perpendicular bisector. Okay, if you are not sure of, if there is still any confusion, let's recap this and you'll understand this question clearly. What are we doing actually? They are saying that Point A is on the curve that has a coordinate 32. We already found in the for part A that yes, there is a point which has on the curve which has y coordinate 32. So we took that point from the working of part A, and then they said there is a point B for which the gradient of the curve is -3. And what does gradient means? Like for example, if this is the curve, this is for example point A that we know, and now there is a point B for which the gradient is -3. That means the gradient of the tangent, that means the derivative at that point is -3. So we are equating derivative that we found in part A equals to -3 to get the value of x, and then substitute it in the original equation of y to get the y. So this is, we are getting the coordinates of point B. We got to be 2, 6. Now what are they saying? Find the equation of perpendicular bisector of AB. So let's join AB first and let's make this perpendicular bisector. Now we need the equation of this red line. So how can you find it? If we know any one point and the gradient of this line, we can find it. So as we are talking about perpendicular bisectors, so obviously it will be passing through midpoint of AB. So for this reason, we found a midpoint. And as it will be perpendicular, so if we find the gradient of AB, the slope of AB, we can just take the negative reciprocal to find the slope of the perpendicular line, the perpendicular bisector. So this is how we have done it, and we got the slope of the gradient, and we got the slope of the AB, and then we got the slope of the perpendicular bisector, and we finally found by point slope form the equation of our perpendicular bisector AB. I hope you understand this. That's all about question number 10, and that's all about this paper 12 of May, June 2024. I hope you understand this whole paper. If there is any confusion, you can comment in the comment box. Any suggestion, any queries are most welcome. So thank you very much, and Allah Hafiz.